Hello, I'm Meredith Blackwell. I'm here at the San Juan, Puerto Rico Convention Center, and I'm attending the International Mycological Congress 11, and I'm going to talk to Joan Bennet, who is a mycologist, and we will have a conversation about her life in mycology. So, Joan.
Well, thank you, Meredith.
Why don't you start out with telling me where you were born and were you raised in Louisiana?
No, ma'am. I was born in Brooklyn, New York, a fact of which I'm quite proud, and spent my childhood there. Was extremely active in Girl Scouts, which got me interested in biology. And at some point, if my parents wanted me to be a teacher, I decided that I was going to become a biology teacher.
And that's how it happened. Yeah, I was a Girl Scout too, and I wonder now how it would be because they're the Scouts. They're still Girl Scouts, but they're also the Scouts, which allow girls and boys.
Yeah.
And that might have been more fun. But anyway, so where did you go to high school?
I went to high school at a place called White Plains High School that was big enough that they actually had attempted majors, and I majored in science, which meant that I took biology, chemistry, and physics. And I remember being one of two girls in that physics class and realizing that a long time ago, not that many women were majoring in science.
Yeah, I never took physics. I took chemistry. We had to have at least one science course, and I didn't take biology because it was considered by me to be a spelling test, and I was bad at spelling. So, where did you go to university?
Well, I started out at a small college named after a famous university in Sweden, Uppsala, and it had been founded by Swedish immigrants.
Are you Swedish?
My father was an immigrant from a Swedish-speaking part of Finland, an island archipelago.
I know that.
And my mother was Finnish. And
yeah, I've stayed right near there, and I could see
it's
the island.
Beautiful gene pool to be from, a beautiful place. And so while I was at Uppsala College, I majored in biology, and I never got around to taking an education course, even though I wanted to be a teacher, and I loved history, so I minored in history. And I had a wonderful botany teacher named Dorothy McMeekin, who now teaches retired Meredith at Michigan State. And my junior year, she came to me with an NSF application for a summer program. She said, "Joan, I think you'd like this program. It's at Cornell." And I said, "Professor McMeekin, I'll never get in that program." And I still remember what she said. She put her arms on her like this, and she said, "Joan, I guarantee you'll never get in that program if you don't apply." She says, "Why not apply?" And so I applied, and I got in.
And you got in.
And I had a wonderful summer doing plant cytogenetics. At the end of the summer, the man I was working for named Robert Sini, he was an agronomist with the Department of Agriculture, said, "Joan, I think you have a knack for this sort of thing. You should go to graduate school and become a plant cytogeneticist like Barbara McMeekin." And I did not know anything about graduate school. My parents didn't have more than a high school education. They thought college was it. And I sure didn't know about Barbara McMeekin. But he told me that if I got in, I'd get fellowship or assistantship, and so I applied to graduate school. Applied to 7 schools. 6 of them were in small towns because I'd always lived right near New York City. And the 7th was the University of Chicago to see if I could get in. The University of Chicago gave me the most money, and that's where I went to graduate school.
That's what happened with my granddaughter, but she also loved it.
I loved it too. Yeah, you've told me that, your granddaughter went to the University of Chicago.
Yeah. So, you finished with whom? Did you work with a mycologist?
I worked with a man who called himself a geneticist. I once did his academic genealogy, and he came out of a fine plant cytogenetics tradition out of Berkeley. And he worked with a man named Stebbins at Berkeley.
G. Ledyard Stebbins.
Yes.
And in fact, when I introduced this this series of interviews, oral history for mycology, the idea came from an interview with Stebbins.
Is that right?
Yeah, at the International Botanical Congress in St. Louis.
That's
where
interesting.
I got the idea.
Well, my mentor, Ed Garber, and I started out doing what I had been suggested to do, and I did a master's on plant cytogenetics on an obscure genus that he was trying to make into what he called a vegetable Drosophila. He was trying to invent Arabidopsis with a genus called Collinsia. It never took on, but
No,
at least
I've
he
never
had
heard
the
of it.
vision. And I didn't like looking at a microscope all day long, and he had another big project on fungal genetics. And so I stayed with Ed Garber, but I did my PhD on a mold called Aspergillus heterothalicus. It was the first heterothalic Aspergillus ever discovered. And that's what I did my PhD work on.
Interesting. And so then, did you do a postdoc or?
Yes, my husband, I had gotten married at the University of Chicago. My husband had not yet finished his degree, so I did a year of postdoc with Ed Garber, supported by NSF, and worked on some plant pathogens, Penicillium digitatum and Penicillium expansum. And interestingly, very recently I've gone back to studying those two molds. And then my husband took a job as Associate Dean of the Business School at Tulane University, and we moved to New Orleans. I applied to the Department of Agriculture and got a job there and did 2 more years of postdoc. And then I had a 4th year of postdoc with a mycologist at Tulane University named Arthur Weldon.
I knew him well.
Yeah.
Well, let me ask you something. Your husband, was he related to the plant pathologist Edgerton?
Yes, he was Harold Edgerton's grandson. His mother was Harold Edgerton's daughter. And I sometimes joke my first husband was a man who loved women and had many, many girlfriends, and I sometimes think he married me because I worked on the same kind of stuff as his grandfather, who was his favorite grandparent.
Oh, how nice.
Yeah.
So he picked you. So you were out at the USDA lab.
At first in New Orleans, I was out at the USDA lab, and I had written a grant to the National Research Council that said that I was going to try to bring some genetics to the study of aflatoxin. Aflatoxin was made by a fungus that at that time had no known sexual stage, and I proposed that I would find the parasexual cycle in it. And in the process of trying to find the parasexual cycle, I isolated many mutants. Some of them were traditional mutants like spore color mutants and nutritionally deficient mutants. And I also selected based on fluorescence for aflatoxin deficient mutants. Found quite a few. When I later was offered a job at Tulane as an assistant professor, I had continued collaborating with the Department of Agriculture and realized that parasexual cycle was a slow, clumsy way to do genetics, and that I'd never get tenure if I stayed with that, but that my blocked aflatoxin mutants were really a useful tool for studying the biosynthesis of a horrible carcinogenic toxin. And I decided that I'd become a fungal biochemist instead of a fungal geneticist.
You probably never worked with Weldon, although you were in the same department.
Except for that year of postdoc, I worked with him looking for wood rotting fungi from the tropics, and I spent a lot of time crossing isolates that he'd found looking for clamp connections. I can remember that year I'd close my eyes and I'd see clamp connections in my cilia and in my visual field. And but you couldn't really work very easily with most of these organisms. They did in fruit. You could grow some mycelium in culture, and it was before molecular biology, so it was a dead end. If you didn't find clamp connections there was not a whole lot you could do. Later on, we could have done some more, but it was too soon.
Yeah. There was a woman in Canada, and Mildred Nobles, who actually had a key to some of the basids, the wood decay fungi from the mycelium. But
I remember reading her
hard,
papers very carefully, Mildred Noble, at that time, and working hard at it, but it was just difficult given the technology of the era to do what we want.
Not many of them had distinguishing characters.
Exactly. So I was glad to go back to Aspergillus, which grows well, mutates easily, and made an economically important toxin.
So at Tulane then, were you there when they divided the department? Or?
Yes, ma'am. I started out in a biology department, proudly to say that I was the first woman they hired, and I did get tenure, and it was actually about 20 years in when the department split into two departments. One department called molecular and cellular, the other ecology and evolution and organismal biology. Big mouthful. And I asked to have a joint appointment, and the dean refused it. And because I taught genetics and molecular genetics, I ended up in the molecular one. I probably should have gone with the other department.
I just heard that a mycologist has become the chair of that department.
Is that right?
Keith Clay, who studies endophytes. He worked with Antonovics at Duke, and when he was at Duke.
Now, looking back, I'm sorry that I didn't go with that department, because the department I was in became very much a developmental neurobiology department. If you didn't work in an animal system, you were just sort of an outsider.
So then, in what year was it that Katrina came along?
Yeah, Katrina came in 2005 and flooded my home. And I've written about this, that when you love a life form, and I do love the fungi, and you are prevented by the National Guard from going home, and you realize that in your flooded home, that life form is just chewing up your stuff. And you know, I knew too much about fungal physiology. I knew that the enzymes were being excreted out into the rugs and into the books, and that it wasn't just going to be mold growing on stuff, but that the molds were chemically changing the contents of my house. And to admit, it really creeped me out to know so much about fungal metabolism and what the hurricane was doing to my home.
But you were very successful while you were at Tulane. You were elected to the National Academy of Sciences.
Now, I for much of my career, although I've been a member of the Mycological Society all my life, spent many of my volunteer hours in scientific societies with the American Society for Microbiology. And I'm proud to say that I'm one of two people who work on fungi who's ever been president of Microbiology Society, ASM. And I think that gave me some name visibility that a lot of people who work purely in the mycological volunteer world don't have. And having been president of ASM, I had met a lot of bacteriologists, a lot of virologists, and now that I'm in the National Academy of Sciences, I know that you get voted for. And name recognition is important.
It has to be.
And I truly believe that my activity for ASM is what gave me the name recognition. And the work came out of studying aflatoxin biosynthesis. We were able to show that the genes controlling the steps of aflatoxin biosynthesis were linked. We beat all the penicillium people on the paradigm that genes of secondary metabolites are found in gene clusters. As a geneticist, I also am delighted that right now the easiest thing you can find in a fungal genome is the footprint of a gene cluster for a secondary metabolite. It's a very, for me, comforting feeling that being a geneticist who worked on molds that were not model systems,
and
we should have stumbled onto something that has been useful in genetics. And
I remember being at your home, since I lived in Baton Rouge
Yeah.
80, 90 miles away from you, and you were in New Orleans, seeing this beautiful bowl that had been engraved with fungi that was a gift from ASM.
ASM. Yeah, they give, it was a glass company in Corning, New York that used to make fancy glass, and so ASM presidents were given a bowl.
Wow, it was beautiful.
Well, thank you. And I have a large collection of mushroom kitsch, as do many people who love fungi.
Not me.
You don't have
I have
one.
none.
I have quite an extensive collection, and I have a graduate student named Toby Feibelman,
Oh, I
former
know
student,
Toby.
and she has an enormous collection, but the person who has the best collection of anyone I know is the outgoing president of MSA, Tom Vokes.
Oh,
and
yes.
he has a home that is just like a museum of mushroom stuff.
I've never seen his home, but I've seen things he's bought at the MSA auction. And one thing I really coveted, but he paid too much. Well, he paid more than I wanted to give for it. But it was a set of king cake, little
babies.
Yeah, but they're mushrooms.
Yes.
And I'd never seen them. I've looked online many times lately, and
I
can't
am
find
very
them.
proud to say that Tom gave one of those to me.
One to you, one to Don Feaster's wife, Kathy.
Is that right?
Yeah, he's
So,
breaking up the set.
yeah,
He picks his favorite people, I think he
I
must.
guess. Well, he knows that I have a collection of mushroom kitsch. Well, in his home, I saw something I coveted, and it's not something he bought. It was a labor of love by a former student with artistic tendencies, and she made him a chess set in which every piece is some kind of mushroom. So they're little inconspicuous mushrooms to be the pawns, and then
Oh, wow.
I think there's a
What are they made
bowling-
out of?
I don't know, some kind of compound
clay
that was
type
baked and then
stuff.
painted.
Oh.
And so there are different colors for the two sides, but I think a morel might be the queen and a bolete might be the king, and
Oh,
perhaps
neat.
the bishops are chanterelles or something. It's spectacular. And I've told him he needs to find a museum or something
Yeah.
to give that to, because it's a one-of-a-kind, over-the-top, absolutely magnificent example of mycological devotion.
Yeah, well, it's probably not quite kitsch. Like
It's no,
your
it-
bowl is not kitsch.
yeah. There are some things that are actually tasteful.
So then Katrina came,
Yes.
and your house was destroyed, practically the insides.
The insides of my home were in terrible shape. The mold had had a play day. I described it as fungal anarchy because the fungi had water, they had carbon sources. New Orleans is hot and humid, so even after the water from the flood had been pumped out by the Army Corps of Engineers, the air was thick with humidity and heat, so the fungi were just in paradise. And they were all over the ground level of my house. And when I came home the first time, I'd been gone for 5 weeks, I traveled with petri dishes and I sampled my house and I photographed what the molds were doing. And I have been working on hurricane molds and their metabolites ever since Katrina. My career took a sharp turn from what I'd been doing, and it's not something I wish on anyone, but I've actually been inspired to teach new and study new things about fungi. And as you know, I'm now studying the volatiles made by fungi, the aroma compounds, and I encourage people who want to find out things that have not been explored. There's a lot of low-hanging fruit. Study fungal volatiles. They're incredibly biologically active. So,
I have a photograph someone took of mold, the pattern on the wall after Katrina, and it's just absolutely beautiful.
yeah,
And I've got it framed in my bathroom of all places. And figure the
appropriate
volatiles.
place. Molds like to grow in bathrooms. They
yeah.
do.
And so you got hired at Rutgers, and in the Department of botany and plant pathology?
Yeah, it was called at that time plant science, plant biology and pathology. Recently, for reasons I don't understand, it's now just plant biology. They got rid of the pathology. But I actually spent the first 8 years largely functioning as a vice president. They had me start an office for women in science. And I worked really hard to do things to enhance the ability of young women on the faculty to get tenure and function in not just in biology and chemistry, but engineering, physics, mathematics across the university. And we had an advanced grant from NSF and several other more teaching-related grants that were focused on women in science, and did that for 8 years, quite fulfilling. And
yeah, I even got to visit my student Joan, who's in your department. Invited me on the advanced grant.
Yeah, we gave out mini grants to young faculty, and one of the things we suggested is that they invite somebody who could maybe write them a tenure letter down the line. Now, you would have written her anyway.
I would have written it, yes.
But
Ning was great.
But I can remember you coming over to our house for dinner, and I had a dog who was not very well behaved named Boudreaux, from a Louisiana dog, and he was wanting to sit in your lap. He thought you were great, Meredith.
I love dogs. I love dogs.
Yes, and Boudreaux loved you. And Boudreaux, I'm happy to say, is still with us, although he's now an old dog. And he moves slowly, but he's a great dog.
Well, it was appropriate that while we were talking, there was a comfort dog that's been around the meeting. It's the first one I've ever seen, but he was really barking. He's been barking, he or she has been barking a lot today.
He doesn't like mycology? Okay.
Yeah, I think maybe that's it. Smells spongy. I actually had a dog once that could sniff out slime moles in the grass, Bistrum cinerea.
Wow, yeah.
There must have been some volatiles there, even if it was a slime mole.
When I first got to Rutgers, I learned that there was a company that was checking mold in buildings that had paid a lot of money for a dog, it was largely a black lab. It was some kind of hybrid dog that had been trained to sniff out mold. And the dog's name was Oreo because it was mostly black, but it had some white on it. And she came and gave a special demonstration to my lab one day. We had a lab meeting for my group, and Oreo visited us. And unfortunately, Oreo has gone to dog heaven, but they are good at sniffing mold. And this company, which was a reputable mold remediation company.
Yeah, although they aren't all.
They aren't all, but this
one
was, and they recognized that often houses that feared they had fungal problems, there was no visible mold, and that if you just sample air samples of spores, it's difficult to know what's going on because hidden mold is not necessarily releasing vast quantities of spores into the air, and yet there may be a big problem behind building material.
So the volatiles may.
And so the volatiles, the mold sniffing dog could detect low levels of volatiles, and then they would do more invasive things to try to find where the fungus was. And
have you heard of the Eco Dog program at Auburn? I guess it's still going on.
Eco Dog.
They train dogs to sniff out snakes in the Everglades, boa constrictors that have been released.
Oh,
and
or
so they
python?
Can, yeah,
all of those python?
Yeah,
wow.
Exactly. And then they also can do other ecological things, but the one that really caught me was one dog was trained to do 4 different fungi that grow underground. Wow. And a 5th signal was given when there was more than one fungus detected.
Dogs are amazing. Dogs are amazing. Olfaction is amazing, and I will, for the rest of my life, be fascinated by odors of all kinds, not just fungal, because once you get fascinated by smells and the chemicals that make them, you realize that we, as humans, I think, underappreciate our ability to smell things and how much some of those smells may be affecting us either subconsciously or even if consciously more than we may think. And I'm at the point where I believe that we have chemoreceptors, not just in our nose, but perhaps in our skin and whatever. They're sensitive to odors. And my advice to people is if something's smelling really bad, and you're feeling bad in a particular atmosphere, get out.
Yeah.
There may be toxicology going on in the atmosphere.
Do you get lots of calls from public?
I get my share of calls from people who are sick, who think it's mold in their homes, who are wanting me to testify in court, and I say no, but
Yeah.
I try to be sympathetic because the science isn't there. We're not sure, but there are a lot of people who are sick who feel that it's due to mold.
And I often have parents call and their children aren't performing well in school and they're not doing this or that. And I think they want someone to be able to blame, perhaps.
Yeah.
It's really
And-
sad. But
And the other thing is that I think there are health problems with indoor environments that we don't understand. And there have been a few cases where it's been worked out, like maybe 20 years ago there was some kind of adhesive chemical that was used for putting down carpeting.
Right.
And it was shown to be horribly toxic, and they've stopped using that. And that was a good, clear signal. Many of the indoor health problems, we simply don't know whether they're real or not. And I also think there's individual variation, just like not
definitely.
everybody is allergic to chocolate or to peanut butter. I think there's some people who are ultra sensitive, not just to molds, but to other indoor contaminants and biofilms that may exist in showers, and it's hard to get funded to study it. And so we don't know, and that's what I tell people who call me. I say, hey, I think there's a good chance you may be sick from something in the indoors, but there's not enough science for me to go into court and help you try to get money from your realtor.
And I've never found out what really happens with Stachybotrys.
Yeah, I've spent a lot of time studying Stachy, and I know, for example, in New Orleans after Katrina, I was looking for Stachy. I didn't find any. It's slow growing.
I found one colony out of thousands because I was sampling dark colonies in some of the houses over, I can't remember the area. What was one of the flooded areas?
Yeah.
Rather small houses built after World War II. But one colony was truly Stachybotrys.
Yeah. Well, I've found Stachy apart from the hurricane one time in a New Orleans house that had a lot of black mold growing, and it had to do with leaks from a bathroom, which was a different kind of situation where it had gotten a foothold. But it's slow growing, and the other thing is the spores are heavy. Most of the toxin is in those heavy spores, and so they don't aerosolize well. It's a terrible toxin. There's no question that I think the fungus in large quantities could make people sick. There usually isn't evidence that the large number of people who claim they are sick from fungi in houses have been exposed to that one.
Right.
And mostly we have questions, not answers.
And I know you know the Sloan Foundation and the work they've done with indoor air. But I know one of the young Canadians that had a grant from the James Scott, who's in Toronto, he has been studying that and even have a test house where they can change the conditions.
Oh, neat.
And I was hoping he would come up with some standards, and he may do that yet.
Yeah.
But standards for testing.
Yeah. No, that I'm glad to see the Sloan Foundation's been studying this sort of thing, and as you may remember, 2 years ago they were instrumental in getting the National Academy of Sciences to do a consensus study, and once they seeded the study, more money was contributed by the Environmental Protection Agency, by the National Institutes of Health, and my favorite of the donors, the Aeronautics and Space Administration, because as I like to say, you can't open the window on a spaceship, and they have some real problems with mold growing in the indoor environment. And if you want to get scared about life in space, go on the internet and Google mold Mir space station, and there are some truly terrifying pictures of mold growing on the wiring in the Russian space station that make you very, very nervous about the ability of that particular man-made object to sustain life for the long run.
I worked at NASA Houston one summer, and it was for Apollo 13, and I was supposed to look at molds and things later. But one of the women who worked there, Mary Henney, who was a student of Dr. Alexopoulos, she actually had the job of swabbing all of the astronauts, where I don't know, but
Well.
she swabbed the astronauts, she swabbed down the space capsule, all the places that you could imagine to see what was there,
Right.
so they would know
where things are
what they
coming.
were taking up. Well, that was before the space station.
Yeah,
but-
well, as you know, it doesn't take many spores to start a colony, and when you're enclosed in a space station and atmosphere, people have to breathe, people have to urinate, people perspire, people have to eat, and moisture then gets circulating, and as I say, there's no ventilation, so they have some major problems with the growth of biofilms, but especially mold.
Yeah.
And they haven't solved them, but they're willing to spend some money at studying this problem, which most agencies aren't, and that's why we still have more questions than answers. And until funding agencies realize that this is a major problem, and as people spend more and more time inside of houses, it's not going to go away.
Yeah. So,
Okay.
well, anything else you'd like to say before we?
Just that it has been a very, very exciting career, way more than I knew it could be when somebody assigned me a role model. And it wasn't a bad role model to be assigned. Barbara McClintock, who was a corn cytogeneticist, did work in corn that boggles the mind. She discovered that genes can jump around and be transposable elements, and so I'm very grateful to Robert Cini for having given me such a fine role model before I was smart enough to find one for myself.
It was actually years after she did the original work
That they
it.
recognized her. It took molecular biology and in working with viruses and bacteria to realize that this woman, and so she's also a great role model for women in science, and that women have always been able to do great science. We haven't always had the opportunity to do great science.
When I was in school in Austin, she came for some period of time, but nobody knew it, and we didn't really know who she was, but we always knew she was famous, and so we would go and look at her through a window. It was funny, but it was thing graduate students would do.
And that says something to longevity, because she lived long enough for people to realize work that she'd done decades before was incredibly important.
Or they wouldn't have been able to give her a Nobel Prize.
That's right,
if she'd died.
and God bless the Swedes for doing it. They should do it more often for women.
For women. Okay. Thank you so much, Joan.
Thank you,
I've
Meredith.
enjoyed it.
And me too. You know, I'm glad you're doing this.